Hi everyone, I'm Vašíček and this is my colleague Blahník.
Hello.
And we are working in Wood & Company as a developer. Our presentation will be in first part about RabbitMQ. I will guide you through this part of presentation, and my colleague will continue in second part, and it will be about backend for front end pattern. Okay. So Wood & Company. Wood & Company is investment company which operates in many areas like trading on stock markets, wealth management, investment banking, and real estates. And today we will talk about client portal for wealth management. And this portal has two main parts, front-end and back-end. Front-end is developed in Vue.js, and back-end is written in .NET 8. For communication between these two parts, we're using RabbitMQ. On this pictures is client portal. So what is RabbitMQ? RabbitMQ is a system for asynchronous communication between systems. It's open source middleware, and classic use case for this system is that there are publisher which is sent a message to RabbitMQ. RabbitMQ store the message in queue, and another system like receiver receive the message or consume the message. Okay, so what is message? Rabbit on the picture is representing the message. In this presentation, the lumps of woods are body, and bubble contains headers. Headers are additional information about message, and body contains content of the message. Body can be anything what you want. It's XML, JSON, byte array. Okay, and headers. One header is key value pair. Key is some string, unique string, and value is anything what you want. It's okay, again, number, text, byte array. Okay, another important parts of RabbitMQ is exchange. Exchange is for routing the messages. Exchange routes message to another exchange or to queue, and message always ends in the queue, and then receiver consume the message from the queue. Okay. So how we use the RabbitMQ in our solution? It's we are using for security, for scalability, and for parallel processing. So for security, we have two environments: public, which is internet, and the second is private network in Wood & Company. So in internet, we have a server with IP address, and on the server is deployed client portal, is application in Vue.js and web API. So client portal communicate with the web API through the HTTP protocol. So client portal sends HTTP request to web API. Web API transform the request to message and send to Rabbit. And on the server in the public, but server has open only HTTP communication to the internet, only for client portal or web API. So there is important that the direction, because for security it's important that the service in Wood & Company can connect to RabbitMQ, but only from Wood & Company, not the second way, okay, from a public server. And this is the security. And the service in Wood & Company consume the message, transform the message to the response, send the response as a message to RabbitMQ, and Web API consume the message and transform the message to HTTP response. So now I prepare request processing in RabbitMQ. So how I said, the Web API transforms the HTTP request to message, and this message has two main headers. First is node. First is node, and the second is type. Node is for routing between instances of services in Wood & Company, which is scalability. You can add or remove service, and this is the first exchange, and the second exchange routes the message to queue, and by type. And type, this header means that on Web API there exist some controllers, and controllers are a group of endpoints which same topic. For example, if you have security, then you have a controller for security, and type messages from this endpoints are set as security. It's set type security. Okay, and then the message with the type of security ends in queue for security messages. Okay, and then service in Wood & Company connect to queues and treats the queues by receivers. Each receiver has own queue, and this is the parallel processing where each receiver consume the messages from queue separately and parallelly. Okay. So after receiver consume the message, prepare the response for it, and send the response as a message to RabbitMQ, and there is the processing of the responses. This is the same, but only I switch publisher and receiver. Now publisher is service in the Wood and sends the message to RabbitMQ. First exchange routes the node, and the second exchange routes the message by type, by header type, and finally Web API as a consumer of the responses reads the messages and transforms the messages to HTTP response and send the response to client portal. Okay, and now there is possibilities of settings of Web API and services and RabbitMQ. The first picture is our current solution, and important is the third picture where we have two Web API. This is example when first Web API can be for client portal, and second Web API can be for special client. Okay, that needs Web API separate. Okay, and the last picture is combined previous pictures. Okay, so now I finished. This is all from me, and my colleague continue with.
Yeah, thank you. So Jan introduced you to our backend architecture, and I'm here to finish the job and get the data from the API to the client. So for that, we use backend for frontend pattern, or BFF for short. And BFF basically means that we have tailored responses for each particular front-end that is consuming our API. That means desktop, mobile, and possibly others. With that, that means that the backend needs to be aware of the target device that will be displaying the data and sends them in a format that is appropriate for their rendering. We mostly introduced this pattern to reduce code complexity on the front end and move it and contain within the backend. So front end just displays the data that it receives. I have just in quote because it doesn't mean that our front end is done and developers can go home, but it means that they can focus more on rendering and UI and UX improvements instead of business logic and handling complex cases. BFF also allows for better optimization and caching. As with traditional APIs, the front-end might need to call several endpoints or services that in themselves might be well optimized, but still BFF takes it a step further and allows us to optimize the data combination with respect to their transformations. We have come to using this pattern iteratively. First, we built a simple REST API that just provided raw data to the front-end client. But that meant that we had to duplicate a lot of the logic on both backend and front-end. So we decided to simplify this and help front-end a bit by sending some flags or pre-formatted strings that the front-end could use to decide which case is suitable for the currently displayed scenario and insert the text use the pre-formatted text within the website. But this created some confusing structures as the front-end needed to work with both raw data and these pre-formatted strings and put it all together to format the final visualization. So that's one day this got too big and too confusing. So we decided to take the next step and go to the entire backend for front-end pattern. Which means that we moved to the structures that well, basically the BFF pattern means that it allows us for faster front-end development, especially when having multiple front-ends, as it reduces code complexity on the front-end side and moves it to backend, and also allows us for better possibilities to improve performance, as I already mentioned, with caching and other ways. The most obvious disadvantage is increased backend complexity. This is natural. Sadly, BFF is not some magic that you sprinkle into your code and suddenly everything is 10 times less difficult to create. You just move the logic to backend, but it still needs to be done. Also, it introduces a tight coupling between the backend and the frontend, meaning that the web API is less reusable. And if a client, for example, wanted to consume our API directly and not through our frontend, they would need to understand some complex data structures that we are sending from the backend, including some formatting, etc. And it would be very impractical for machine-to-machine communication, as a parser would be needed to extract the raw data back from the formatted structures. And that is all from us. So now we have some time for questions, if you have any.